Oh, hello, my student. The script going to talking about the laboratory number one is will about the inspection of the material testing laboratory. There is a learning objective to let you know the testing machine, equipment, specimen that's used in this lab, and understand the rules and regulation and safety precaution of using this lab. Okay, and the detail about this I will elaborate to you later. The second, this lab, I will make the change for you guys to write the report. Last year, the laboratory report is produced by handwriting, but this year you are going to use the Microsoft Word to produce the report in accordance with the details in chapter 1. So we don't use engineering paper now, and also the basic drawing equipment. We may need to find the picture of the testing machine or equipment and specimen. Most of them are in my lecture, so you may bring those to put in your laboratory and try to write the detail of each specimen, the suggestion and the other things that are required to write in your lab. So the procedure supposed to be changed. This time, after I divide you guys into groups and I make the clips, I will show you the machine and the details of its testing by the video clips, and then I will do correct the data from the clips and writing the laboratory report. Okay, guys, you may understand that, right? I will divide you guys into groups, and then you guys watch the clips and each of you write the report. And the first one, I like to introduce you the Poisson ratio of the rubber testing machine. This machine is a frame, it's a steel frame. The rubber is here, okay, it's hanging by a support here. When you put the weight onto this rubber specimen, the specimen will elongate, and it is intention, right? That means the length of the rubber gonna increase, and at the same time, if you measure the width of the rubber gonna be decreased. You may bring a rubber band and try to pull down. You will see what I'm saying. It's going to go longer longitudinally and going to get smaller laterally. In this lab, they like you to study the behavior of the rubber by putting it in tension. Okay, and then if you start by specify the original length of this rubber band, and you measure the L sub O, and you measure the B sub O, the width. Okay, when you increase this, the L sub O will change to L sub 1. You made an L sub 1 with L sub O, you get the elongation of this rubber band. And then when you divide it by original length, you get the longitudinal strength. Also, you got the original width. By putting the weight into the rubber band, the width reduce or decrease. And then if you measure the new width minus the old one and divided by the old one, you get the lateral strain. Okay, and you may go back to the textbook chapter 3 of the mechanics of material about the Poisson ratio. The Poisson ratio is the minus of the strain in lateral direction divided by strain in longitudinal direction. Since the minus and the minus of the lateral strain, the value of Poisson ratio gonna be positive. And most of the time, the value of the Poisson ratio is in between of 0.4 and 0.5. How about the stress? Since you put the weight, you know the weight of this, and you also know the width and the thickness, so you can determine the cross-sectional area of the rubber band. Usually, you may need to measure 1, 2, and 3 times between the given length you have. And then you get the stress. So you can plot the stress then curve of the rubber band, and then you can determine the modulus of elasticity of this rubber band. By using this, just beware about the weight gonna drop down into the floor, and also beware about your foot or feet. If the weight drop and then it hit your feet, that's going to hurt. Next, this machine is the universal testing machine, 20 kilonewton. The 20 kilonewton is maximum force this machine can apply. The mechanics of this is start by when you twist this knob, the hydraulic pump will pump the hydraulic oil into this load cell, and it's going to tell you by the black needle. And also you're going to have the red needle. Red needle is to record the largest force. So during the applied force, you got to put them together, and then before the before the material fail, the black needle will come back, but the red needle will stop at the highest point. And then when the hydraulic oil coming into this pump, it's going to move this part, this frame. It's going to move together, move up. And since this frame is fixed, okay, when this one is moved up and this one is fixed, you put the specimen here, that specimen going to be in tension. And again, by moving here, the bottom is going to move, and this one fixed. If you put specimen here, the specimen is going to be in compression. Or if you put the beam here, the specimen is going to be in bending. Since this one can test the tension for laboratory 3, test the shear for laboratory 10, and test the compression for laboratory 12. This name of the machine is universal. That means generally testing machine. And the specimen for the tension test is here. One is the cast iron. This one is steel. And this one is brass. This one is copper. This one is aluminum. And this is the steel plate for the lab 12. Next, I like to introduce you the torsion machine. We're going to test the steel is here, and the cast iron is here. And if you like, you may test the brass like this. This machine composed of this knob is going to produce the torsion, and this going to measure the rotation of the specimen. When you put this specimen in between these parts, okay, and when you rotate this going to produce the torsion to the specimen. And if you put the torsion into the equation tau equal to TR, R is the radius of the specimen, you can measure it, and divided by J, the polar moment of inertia, you will get the tau. This part going to measure the rotation of the specimen, and you can compute the shear strain by that rotation. So you get the shear stress, shear strain from this machine. By using this machine, just beware about the failure of the specimen. Next, this machine is the 2000 kilonewton or 2 million Newton compression testing machine. This guy will be in laboratory building F4. The machine before this one is in the laboratory building F5. This machine is the compression testing machine. The mechanics of this having the hydraulic pump here. When it's pumped, the pressure of the hydraulic pump will measure from this transducer and show over here as the force. And at the same time, the hydraulic oil will move to this lower part, and then it will push the bottom part up, and the top is fixed. Okay, by putting this up, that means you apply the compression to the material, such as the wood, such as the concrete, or such as the brick. Okay, and if you like to measure the displacement of this moving part, you can put the strain gauge in between these two portions. This machine is quite versatile, can be used in many laboratories for the lab 5, lab 6, and lab 7. Most of them are in compression. And this term, this machine going to use in the shearing the wood also. So only this machine can take 4 labs out of the 12 we have. Next, this is the 100 kilonewton universal testing machine, and it's going to use to test the fracture of the wood, fractural tests of the steel and the cast iron. The mechanics of this is start by pumping the hydraulic oil, and then hydraulic oil move into this hydraulic cylinder, and then it's going to push this part off. Okay, the frame over here will move when this one move, and this portion of the machine going to be fixed to the foundation of the machine. So when this one move, that's this portion going to be in compression, and if you put the beam between this, the beam going to be in friction. Okay, the load will show here. Okay, and if you like to measure the displacement of this portion, just put the dot gauge between the foundation and this portion. Okay, this guy gonna use for 2 laboratory, number 8 and number 9. And for the number 11, I'm going to move it to the compression testing machine. And this one is a fatigue testing machine. This machine have the motor here, and it have the shaft here linked to this portion to give the specimen support. Okay, when you rotate this, it's going to push the specimen up. So the bottom of the specimen going to be in tension, and the top going to be in compression. However, when you rotate it, the tension and the compression going to change. By starting this machine, you got to put this knob, and when it's rotated, it have a scale here to count the number of rounds the specimen move. And when the specimen fail, you just put this button to stop the machine. And beware about the breakage of the specimen when it fail. And the last 2 machine is the universal testing machine. Usually we use this for commercial purpose. Okay, at this point you may get the knowledge of every machine that we support to use. Okay, For the laboratory report, you got to use the Microsoft Word to produce it in accordance with the chapter 1. Okay, and you got to put each testing machine picture into the report and write the detail as the following example. So this is the detail of the testing machine, the universal testing machine. This is the lab that's going to use this machine. This is the detail of important part of the testing machine. This machine also, you need to put the picture here, what it's going to use in the lab, and what portion of the machine that are important. So you got to answer some basic question A, B, C, and D into your laboratory report, and then when you finish it, you got to turn in within 1 week. Okay, and please convert the Microsoft Word file into the PDF and post it into our Google Classroom, and beware about the due date and time. If not, you're going to get a big problem. Okay, thank you very much for your attention.